Okay, hi, good morning to everyone. Okay, so welcome back to our class. Okay, for this week, okay, we're going to learn about inverse variation. Okay, 1.2 inverse variation. Okay, for last class, you have learned about direct variation. Okay, so I hope you understand what is direct variation and you have completed your assignment. Okay, so for today's lesson, okay, the learning standard, the first one is explain the meaning of inverse variation. Okay, so what is inverse variation? Okay, in inverse variation, okay, variables y increase when the variables x decreases, okay, at the same time, at the same rate, and vice versa. This relation can be written as y varies inversely as x, okay, or the other way we can write it like this: y is varies inversely as x. Okay, if it varies directly, you will write it on top of this fraction. If it varies inversely, you will write on the bottom part of the fraction. Okay, because we know the relationship is inversely. Okay, okay, what is the real life situation that can you relate with inverse variation? Okay, for example, okay, if you spend a lot, your money will decrease. Okay, such like that. Okay, can you get the example? Okay, okay, so we look at the first example, example 15. Okay, Chia Ming takes part in a 42-kilometer marathon. The table below shows the relation between the time taken by Chia Ming and his average speed. Okay, you can refer to the table. Okay, state the change in average speed. Okay, average speed if the time taken: A increased by 2 times, B decreased by 1.5 times. Okay, for A, you have a look at the table. Okay, for example, here we have T and V. Okay, the first one we take 4 for example, okay, and then 10.5. Okay, if the time increased by 2 times, okay, it means we need to multiply by 2. So 4 times 2 is 8. Okay, so over here, take a look at this 8. Okay, what is V? So its V is 5.25. Okay, so if you see on that table, okay, if the time is multiplied by 2, you can see that the value of V is decreased by 2 times. Okay, can you see that? Okay, so what can we say about this is, okay, when the time increases 2 times, then the average speed decreases 2 times. Okay, so can you relate it with this one? Okay, for example, I write it down here: y, sorry, it's t 1 over v. So if your value of t increase, your value of v will decrease. Okay, okay, same goes with b. Okay, so for B, I want you to try it yourself. Okay. Okay, so for self-practice 1.2a, okay, so this is your first assignment for this week. Okay, so number 1 and number 2. Okay, later I will assign this assignment in our Google Classroom. Okay, now we proceed with the next learning standard. Okay, determine the relation between two variables for inverse variation. Okay, look here. Okay, we can relate the two variables x and y in the form of equation. That is, x times y is equals to k. So we know that y is equals to k over x. Okay, so this is the relation for inverse variation. Okay, if you remember from the last class, the relation for direct variation is y is equals to kx. This is for direct variation. Okay, so now add in one more. Okay, so for inverse variation, okay, so you have y is equals to k over x. So you see the x is going to the bottom of the fraction because it is inverse. Okay, now look at this yellow box. Okay, for an inverse variation, y varies inversely as x can be written as, okay, so this is the variation form. Okay, and when you convert it to equation form, okay, just like the previous class, okay, you change these symbols to equal and then you add in k, okay, where k is a constant. Okay, I show it to you guys here. Okay, in the variation relation you have y, okay, inverse, okay, so y varies inversely to x. Okay, if you want to change this variation relation into equation form, what you need to do is just simply write y, okay, equals to, you add in k, okay, over x. Okay, so in general we can say that, okay, for an inverse variation, y varies inversely as x to the power of n can be written as, okay, the same thing as the previous one, okay, where n can be 1, 2, 3, half, 13 and such, okay, where k is a constant. You need to know that. Okay, so okay, we look at the first example. Okay, it is given that the time needed T to assemble a piece of furniture varies inversely as the number of workers. Okay, the table below shows the relation between X and T, where X is number of workers, T is the time needed. Okay, so this example is one of the example of the real life situation. Okay, for example, okay, I want, okay, you to help me to clean the classroom. Okay, for example, I only ask Justin and Julian to sweep the floor. Okay, so maybe it will take around 30 minutes for them to clean the classroom. What if I invite 5 to 6 person? Okay, so you know that, okay, the time taken to sweep the floor of the class will be more faster. Okay, it is one of the great example for this inverse variation. Okay, so back to the example. Okay, By calculating the value of, okay, x times t and x squared times t, determine whether t varies inversely as x or x squared. Hence, write the relation by using the symbol variation. Okay, so the first thing you need to do is you need to build a table. So we have 1, 2, 3, 4, 5, 6 column. One, 2, 3, 4, 5, 6 column, 4 row. Okay. 1, 2, 3, 4. Okay, we have x, t, xt, x square, t. Over here we have 2, 3, 4, 5, 6, 180, 120, 90, 72, 60. Okay, so x times t is 2 times 180. So you will get 360, 360. This one also 360, 360, 360. Okay. Next, the value of x squared t. Okay, so x squared. So x squared 2 square is 4 times 180. You will get, when you press your calculator, so 720. Next one is 1080, 1440, 1800, 2160. Okay, so from this table, okay, you can see that at the column x times t, you already get a constant value of 360. Okay, so what is the conclusion? Okay, we can say that, okay, the value of xt is a constant, whereas the value of x squared times t is not a constant. Hence, t varies inversely as x. That is, t varies 1 over x. Okay, so next, okay, example 17. Okay, two quantities x and y vary based on the table on the right. By using a suitable scale, draw a graph of y against 1 over x and show that y varies inversely as x. Okay, so the question 1, we to draw a graph y against 1 over x, and then we need to show that y varies inversely as x. Okay, so we need to build another table. Okay, just a simple one. Okay, so inversely as x is 1 over x. So what is 1 over 2, 1 over 4, 1 over 5, 1 over 10. So 1 over 2 is 0.5, 1 over 4 is 0.25, 1 over 5 0.2, 1 over 10 is 0.1. Okay, and our value of y remains the same. Y is 8, 4, 3.2 and 1.6. Okay, now we need to plot this table. Okay, I just roughly sketch the graph for you guys. Okay, for example, this is 2, 4, 6, 8, and then this is y axis, and this is 1 over x. Okay, so for example, this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. Okay, we need to know the plotted graph must be a straight line and passes through the origin 0. Okay, so we plot the first one is 8 0.5, 8 0.5 around here, 0.25 and 4 around here, 0.2, 3.2 around here, and 0.1, 1.6 around here. Okay, so when we draw connected all the dots, it must be a straight line and passes through point 0, 0. Okay, then we can conclude it as the graph of y against 1 over x shows a straight line that starts from the origin. Okay, hence y varies inversely as x. Okay, so basically these two example, okay, it's just want to prove it to you guys. Okay, is it the values is inversely or not? Okay, and how to prove it to be in a inverse relation. Okay, now we move to example 18. Okay, it is given that x equals to 0.25 when y equals to 3. Express y in terms of x. Okay, express y in terms of x. So your final answer must be y equals to something something x. Okay, so you can refer to these notes over here. Okay, so the first one, okay, A, it mentioned that y is varies inversely as x. So y 1 over x. So we need to change it to the equation form. So y is equals to k over x because it inversely. Okay, now the first one, we need to find the value of k by substitute the given value of x and y into this equation. So y is equals to 3 is equals to k over x is 0.25. Okay, so the value of k is 0.75. So we know that y is equals to, you need to substitute back the value of k, 0.75 over x. Okay, that's it. So this is express y in terms of x. Okay, next B, y varies inversely, okay, 1 over the square root of x. So this is the square root of x. So we need to change it into the equation. So y is equals to k over square root of x. Okay, first we need to find the value of k. Okay, so from the question given, the value of y is 3 is equals to k over square root of 0.25. So k, you press the calculator, so k is equals to 1.5. Okay, hence okay, y is equals to 1.5 over square root of x. Okay, as simple as that. Okay, next we proceed to example 19. Okay, the force of a gravity F, okay, varies inversely as the square of the distance between two objects D. Okay, please be careful with square of and square root of. Okay, it is given that the force of gravity between two objects is 15 Newton when the distance between them is 1.2 centimeter. Okay, so we know that from the question, okay, F is equals to 15 and D, distance, is equals to 1.2. Okay, so from the question, okay, we need to write this equation. Okay, so F, okay, varies inversely, so 1 over square of distance, so D square. Okay, next change it into equation, so F is equals to K over D square. Okay, find the value of K by substitute in the given information from the question. So we have F is 15, K over D is 1.2 square. Okay, so you press your calculator, so K is equals to 21.6. Okay, hence F is equals to 1.6 over D square. Okay, I hope you understand my explanation for this example. Okay, proceed to example 20. Okay, it is given that P, okay, P varies inversely as Q, so 1 over Q. So change it into the equation form. So P is equals to K over Q. So P from the question is 2 is equals to K over 7. Okay, then K is equals to 14. So, okay, we know that P is equals to 14 over Q. Okay, is it finished? Not yet, okay, because the question asks you to do another step. Okay, calculate the value of P when Q equals to 1.6. Okay, so when Q is equals to 1.6, okay, P equals to 14 divided by 1.6. So your final value of P is 8.75. Okay, actually there is another alternative method to solve this type of question, where you can use the concept of proportion. Okay, so I show it to you guys. Okay, we know that, so this is inversely proportion. Okay, so we have P1 Q1 is equals to P2 Q2. Okay, actually, how can you know it P1 Q1? P times Q. Okay, actually it's as simple as that. Okay, you look here. Okay, for example, we have P is equals to K over Q. So K is equals to PQ. That's why you use PQ, because we know that both of the side, okay, have the same K. Okay, so P1 is 2, Q1 is 7, okay, is equals to, okay, P2 times Q2. Q2 is this one, the second value, okay, 1.6. Okay, so P2 cross multiply, okay, you get 2 times 7 over 1.6. Okay, so you will get the same value, 8.75. So this is alternative method where you are going to use the concept of proportion. Okay. Okay, so self-practice 1.2b. Okay, so there's a 7 question over here. Okay, although it looks like quite many 7 question, but it's actually a simple one. Okay, you can finish it in 15 to 20 minutes only. Okay, so this is your second task for this week. Okay, I want you to do question number 1, number 2, number 3, number 4, number 5, number 6, and number 7. Okay. Okay, let's proceed to the last learning standard for this week's class. Okay, so the learning standard is solve problem involving inverse variation. Okay. Okay, so look at the question. Okay, according to Boyle's law, the gas pressure P of a mass of gas is inversely proportional. Okay, I've stated here inversely proportional to the volume of the gas V if the temperature of the gas is fixed. The diagram on the right shows the gas trapped in the cylinder when the volume inside the cylinder is 80 centimeter cube. The gas pressure is 190.25 kilopascal. Calculate the value of the gas in centimeter cube when the gas pressure inside the cylinder is 1 to 1.76 kilopascal. Okay, so how to solve this type of question? Okay, I map out for you how to solve it. Okay, the first step, what you need to do is you need to understand, okay, the problem. Okay, what is the problem actually? What the question asks you to find? What is the given information? You need to know all of that. Okay, from this question, okay, you know that P is inversely proportional to V, right? So P is inversely proportional to V, 1 over V. Okay, and then also given that V is equals to 80 when P is equals to 190.25. Okay, so this is the first step. The second step, okay, what you need to do is devising a strategy. So in order to solve a problem, you need to have a strategy. Okay, so in this problem, okay, the strategy is, okay, first we need to determine the relation between P and V in the form of equation. Okay, hence we can calculate the value of V when P is equals to 1 to 1.76 kPa. Okay, so that is our strategy. Okay, so strategy first, we need to determine the relation in the form of equation. Okay. Okay, so next, number 3, the third step is we implement our strategy. Okay, implement strategy. Okay, so we have, okay, P is inversely proportional to V. Okay, so we need to convert it into the relation, this relation in the form of equation. So we have P is equals to K over V. So next, we need to find the value of K by using this information. Okay, so substitute the two values. So P we have 190.25 is equals to K over V is 80. Okay, so K, you press your calculator, we know that 190.25 times 80, we get 15220. Okay, hence the complete equation, okay, P is equals to 15220 over V. Okay, so this is the equation that we are going to use to solve this problem. Okay, and for the last step, okay, I use another color, purple. Okay, so when P, okay, this part, okay, when P is equals to 1 to 1.76, okay, so what is the value of the pressure? So 1 to 1.76 is equals to 15220 over V. Okay, so V, okay, you know that V is 15220 divided by 1 to 1.76. You press your calculator, your final answer is 125 centimeter cube. Okay, so just like previous class, okay, the last step is we need to make a conclusion. So the conclusion is, okay, very simple. Okay, when P is equals to 1 to 1.76 kilopascal, okay, so the volume is 125 centimeter cube. Okay, so if you have a difficulty to understand my explanation, okay, you can just rewind this part. Okay, you can rewind and play it over and over again until you understand. Okay, because I think this chapter is quite easy. Okay, and then this is the last part, self-practice 1.2c. Okay, so I want you to try this. Okay, so this is the third assignment for this week. Okay, self-practice 1.2c. Okay, you have 3 simple questions over there. Okay, how to solve it? Okay, you can refer to this example 21. Okay, so please don't forget to comment below your name and your class for your attendance. Okay, and then don't forget to fill in the Google form for your attendance also. Okay, if you have any problem regarding self-practice 1.2a, b and c, okay, just personal message me, WhatsApp me, text me, or whatever you feel comfortable to do. Okay, and I will assist you over there. Okay, so I think that's it for this week's class. Okay, and for next week we are going to go into the last subtopic 1.3, and then we try to do a simple SPM question type of question. Okay, so that's it for today. Okay, thank you very much. Okay, bye.